Okay, so welcome back, guys. This is the 17th meeting of the GDC, and we are almost close to the ending of the second project. So it could get a bit emotional for some of you, and it would be a bit exciting for some of others. Some of others, my bad. Um, but what we're gonna do in the next project, as I said, it's gonna be a first-person shooter game. So it's gonna be a bit more exciting and a bit more fun. I hope at least, and maybe we could learn a thing or two from that new project. But before we, even start going into that kind of stuff, we have to start ourselves. You need to basically finish making this rocket game. Um, a lot of you guys are doing a lot of good work, and you guys are submitting the assignments. I've just seen some of you guys submit these things. So one example is Oli. So great job, Oli. Thank you for sending. I think he replied to some of my messages, so I think I need to check that. But as I said, this is really great. So thank you very much for doing such things. Okay. Today I actually want to talk about something that I want to give you some updates on what I did in the past few weeks. Right after I left the previous meeting, I made some changes in my entire game. Maybe like not in my entire game, but somewhere in the code, somewhere in the game. I just added some tweakings. Tweakings, is that the right word? I just added some tweaks basically, and I wanted to show you these things first before we actually start the meeting. But before we actually even I show you the updates on what I did, some new tweaks basically. I wanted to talk about the main three to four-ish topics that I want to talk about today specifically. One is refactoring and encapsulation. Number two is cheat/debug key. So I kind of I foreshadowed the message in the last meeting that I'm going to talk a bit about some debug keys, some cheat keys that you could add in your game, so that whenever you have like 20 different levels in your game, you don't really have to play these levels practically. You can just press some button and instantly go to the next level. We're going to talk about the basics right now. Obviously, there's way more to this, and we will talk more about that the moment we go into our next game project. But we want to introduce ourselves to the idea of how cheat keys really work, and then we could progress ourselves up there, like making more features where it can only work for developers, but not the players themselves. Now, obviously, when you're going to be making this game, you could obviously remove the code or just comment it out before you publish it and build it, all that kind of stuff, and share it with people. But this is just a really cool feature, especially for people like us, developers, when we're making games, because obviously not all of us are good at playing games. And second, it wastes our time, right? When we're playing these different levels, and really you want the actual answer, like saying whether you made a change at level 20, has the change really been done, and is it successful rather than a failure, right? And then finally, we're going to talk a bit about how to make our own environment. This is the day. Today is the day. So you guys will have one homework assignment where you need to make your entire environment in your game and basically practically follow that principle, intention to execution. All right. So whatever you intended your game to be. So if you had like a space theme kind of game, then you want to follow that space theme, right? You want to make that space void, so maybe like just a black screen in the background. Or perhaps if you're making a game like in a city, then you want to make the background something city related, and you kind of get the idea, right? And also I'm gonna finally, like, the fourth topic really, which really connects to the third topic, but it has to be a topic itself, because it could help you practically in any other ways as well, especially when you're coding, right? But not right now, but obviously in the future when we start learning more about those things. So I wanted to talk a bit about local and global, and these are type of spaces, these are type of position, basically type of coordinate points kind of system, all right? You'll get more about that like very soon, like once we start introducing that third idea that I wanted to talk about. But that's going to be one of the big things that I need to talk about today, and kind of clarify what's the difference between the local space and global space, which is actually found on the top left. Well, for you guys, it's going to be, I don't know, top right. I can't see it properly because it's flipped for me, the OBS screen. But yeah, you can see that on the top left, like there's like a local/global kind of button. So you're going to see that, you're going to understand what that is more, what that really is in today's video. So really in the future, you'll tend to get that idea that, oh, we use local, not global in these scenarios, or vice versa. All right, so before we begin, let's actually talk about some changes that I made in my own game. So let me just go to my main screen, and I think you guys can see my screen. Oh my, that looks very laggy. I'm really sorry. I'm gonna get a lot of Unity chat messages. Anyways, getting back to the point. So the first thing that I did was I added some sort of looping. Okay, so what about looping? What am I trying to talk about? Well, if you play this game, right? So you will not see what I'm trying to talk about, but I'll try to explain the idea. when I'm playing the game, right? Let it load. I press the space bar. When I keep on pressing the space bar, like holding it, let me just release. Yeah. When I keep on holding the space bar and releasing it, uh, the thrust, that particle effect, it's coming out like bit by bit, right? It's like boom, boom, boom. Okay, but what if I'm trying to hold the space key bar? Okay, like I'm holding it, like I'm just holding it nonstop. I'm not like pressing it, then pressing it, then pressing it. If I was just pressing the space bar, then obviously the thrust should come bits by bit, right? Based on how many times you press the thing, and right after that, it should do the thing. But if you're gonna just press the space bar and just hold it for a long time, you will realize that it's still doing the same thing. It's coming bit by bit, the thrust effect. Not like as a whole, right? Not as a whole continuously, in other words, looping when we're pressing the space bar button. So how do we... Whoa. Sorry about that. So what happened? Like, what do we do to practically say that if we are holding the spacebar button, the thing keeps on looping rather than coming out bit by bit, right? Because that kind of ruins the player experience. The point of having a spacebar is to let the rocket keep on thrusting, and while it's thrusting, the particle effect should be running as long as that rocket is basically doing its thrust. It's basically like in real life. If I'm going to launch a rocket, the engines, not the engine specifically, but the thrust should be going for a long time. In other words, continuously, not like coming out bits by bit, right? The bit by bit part would be up in space when it's trying to move, but still that's not the thrust itself. It's like some sort of white air kind of thing, but that's a whole new effect. But my point here is that was what I was trying to say. We need that kind of looping effect to get that sense of realism in our game. And I want to just make sure you guys can still... Good. Okay, you guys can still hear me. Okay. Oh, crap. Okay. All right, so what we do here is I had to practically go inside of this rocket thing, and we had to think about, wait, so what specific thing is responsible for launching that specific particle, for launching this thrust particle down here, right? We call it rocket jet particle. So what is responsible for that? Which code is essentially responsible for that? So when we go back to our Visual Studio, whatever IDE you're using, hopefully Visual Studio Code, if we go to the movement script, movement.cs, as you can see here, we can see that we have already serialized this main engine particle thing, which has a type of particle system. So this variable is essentially storing something that has a data type of a particle system. Right? And basically, when we go back to our game, so if I go to the rocket itself and go to that script, the movement script, you can see that the main engine particle, well, the rocket jet particle, that's what's being stored. Like the main engine particle variable is storing the rocket jet particle, as I mentioned previously on how serialized field works. Now, if we go back down into the code, we need to figure out which specific area is responsible for processing that inner thrust, the thrust that we have right below us, right? So we actually have a method. We have a process thrust method, which is essentially responsible for the thrusting. So thanks to our comments, we know what this method is practically for. What is its intention in our code? Okay, so let's actually go down there. So if we go to process thrust, this is apparently the process thrust method. And within this is what is going to be running when we run this method. So we can first see, well, if we press the space button, so now we should keep ourselves into alert that this is an if statement. So this condition will only run if this specific, well, these statements is going to run if this specific statement is true. Now, what's what did I just... Okay, just forget what I said. This statement, these set of statements is going to run if this condition is true. Now, what's the condition? The condition is basically if we press the space bar, right? So it's input.getKey, keycode.space, which basically is like a command for saying whenever we have pressed this space bar button. So if we did, then we should run this code. And the code is just practically saying that we play that, thrust sound effect. We then add a relative force. So we move the force up relative to what direction it is, rather than not going up relative to the global environment. That's kind of a foreshadow of what we're going to talk about in local versus global, but that's the idea. But another thing we added was main engine particle was playing. So what this saying is this is going to play the particle effect only if it's not playing, right? And it will play only in this given condition. So we have two different conditions for the main engine. And this is where we access the component. Okay, so now keep in mind that this is technically like an object. Even though I said it's a variable, you should think of it now more of an object because it's storing a type of particle system, which in other words, that I said, even though I said it's not a game object, it's kind of treated as a game object, right? Because you can still see that in the environment. So anything that's in the environment in our Unity scene, you can see that this is still active in the environment. Now, obviously, this is a game object that's storing the particle system component. So in other words, we could also treat these components, specifically these components that you can see within these game objects, a bit like game objects as well, because you're just referencing a class, if you think of it. Let me just go back to the code. In other words, you're basically referencing as an instance, right? So this is an instance of this class, particle system. And this particle system is a type. It's a type of class. And we can see that when we serialize it, we're storing the engine, which is also like a component of particle system. So it's referencing to this particle system class. And I'm talking about left engine particle, but this applies same to main engine particle. And because it's a type of class, like this sort of set of code, and they know that it's the same, we can reference this as an object directly to that component, which is the particle system, right? So forget about what I said about game object. Just think of it as a class. It's a type of blueprint, right? And this whatever we've serialized in, which was the main engine particle, that was also referencing to the particle system class. It was in fact using it. And that means if this is part of the particle system class and we are referencing a type of particle system class, then we can make an instance. If you don't know what instance means, check out the previous video or 2 videos ago. They do talk about prefabs of the instance, which still talks about that idea of instance. It's just we're making an example, like a sample of that type of serialized field, right, which has a particle system. So I talked a lot about that. I hope kind of understand it. If you don't worry, just come back to me. Now, you can think of it as a component, right? So the component itself has different particular features. So if we actually go back to our Unity program and we look at, I don't like the source as particle. Just press stop if anytime these particles come up accidentally. Just press the stop button and you can go back. If you go to the rocket jet particle, and this is basically a game object that's storing a particle system component, which is right over here, we can see that one of the options is looping. All right? It has a trigger of enable or disable. Now, by default, we set it to be disabled, but we want to access the instance that we made in our code. We want to trigger it to be enabled. All right? So what we could do is we could go through our code and set it to true. All right? So we want to say that if the main engine particle if it's not playing already, then we play it. But before we make it play, we need to set the loop to be true. And then we play the thing. Now, the reason why I'm always trying to tell you, you could do it the other way you like, so you could still play and then set the loop to be true. But the reason why I don't recommend it is because particularly for this particle, we set the duration to be really, really small. Okay, so the timing, or in other words, the amount of time that the particle system is going to play, it's very short. All right, and what will happen is you're going to create that kind of glitch effect. All right, and I don't know how to explain it, but in other words, you're going to get that first effect, and it's the first effect of that 0.3 seconds, and then it's going to loop, you know? You kind of get what I'm trying to say? So, in other words, this code is kind of sequential. Sequential meaning it's going to finish this task first, then the task after that. Obviously, it's not going to do that all the time. Usually, our computers are really fast to process everything. But it's always recommended to set the loop first to true and then play it to avoid that chance in our game to get that jitter effect, which again, could ruin our player experience. We never, never, never want to ruin our player experience. Otherwise, your platform, your reputation, okay? You don't want to do that. So let's not do that. But my point is, let's set the loop to be true, and then boom, 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 we gotta play the particle effect. But then we need to tell the computer that, hey, bro, you know, I ain't pressing the spacebar anymore. I gotta stop. Okay, I gotta stop this kind of particle effect to be looping, because if I don't do that, it's going to keep on playing when I'm not pressing the spacebar. So that's a bummer. No. We don't want to do that. So what we do is outside of this, so if we did not press the spacebar at all, we should make an else statement. So what this else statement does is if this condition has not passed at all, so if we have not, if you have not pressed the spacebar, then it's automatically gonna do these set of statements, which is to stop the audio source and to set the loop of the main engine particle to false. Okay, so by default, we will just practically always make it set to false whenever we have not pressed the spacebar. And that's what's really essentially helping us fix that main problem in that looping thing. So then once we have finalized this type of thing, as you've seen in the game, if we play the game, then we should see that thrust looping whenever we have pressed the spacebar. So let's just, and you can see that. Oh, okay, it went out. But you can see that it was continuously looping that thrust effect, so that whenever I press the spacebar, it's going to keep on getting that thrust particle. And if I'm not pressing the spacebar at all, then it's not going to do it at all. It's not going to loop it, and it's not going to play it. So we have fixed that one bug that I've encountered in the previous meeting right after the meeting was done. I saw this problem happening, and it did, and we found a solution to that. Another thing that I wanted to talk about, and this was actually one of your assignments you had to try to do by your own, which was to make, and if let's go back to our prefab, which was to make these rotation particle effects, right? So whenever we rotate left, the right particle engine should come up, should basically be playing, and vice versa for whenever you turn right, the left engine particle should be playing. And if you see, we have already made these side thruster particles. There was a side thruster particle for the right one and the side thruster particle for the left one. And if we go back to the code, we can still, this is still going to be in the movement script because we're still moving. The script is essentially responsible for moving our object, right? So we actually already started really well in the last meeting by making two particle systems for the left engine particle and the right engine particle, which then we go back to our code, go to the rocket thing, which is the parent object, which has all the things for us. If we go to our movement script, we have also added the side thruster particles respectively. So respectively for the left engine and the right engine. So keep that in mind. The thing is, one mistake I have done, and this is something you should try to fix, is try renaming these particles respectively to its appropriate name. So this one should be called right engine particle, and this engine should be called left engine particle. And then, that's just gonna, avoid that confusion whenever you're gonna drag into the inspector panel where it's supposed to be. Okay, so let's actually go back to our code and see what we can do. Now, we need to figure out which part in our code is dispensable for rotation. You found it? It's like Dora. It should be somewhere in the screen. You should see it. Well, if you've seen it, you should have seen it. I'm putting my mouse on it. You should have seen it. It's the process rotation method. All right? And what this process rotation method is responsible for is essentially just rotating our object. So let's go to our method where process rotation is. And it's holding these set of statements, which will run whenever we ask to run practically this method. All right, so we have, and just forget about the else statement down there. Hey, spoiler alert. You want to see all the things already, bro? So we have just ignore the else statement. I'm still telling you. Please, I'm trying to explain. So at first, we had two if statements. One was if, and then else if, which is technically if, but it will only run if this else if will only run if this isn't true, right? So, and if this was true, it's still not going to run this because this became true. So that's why we use else if, not if. If it was if, then this would run regardless of this being true or false. So just keep that in mind. So let's go back to the first one. If input.getKey keycode.a. So now we know that when we press the A button, so this condition is saying whenever you press the A button, and we know that the A button is responsible for turning left. Whereas, for the D key, whenever we press that, we're turning right. So inside of both of these, it has the same method, which is do rotation. But if you see, I added another parameter. Now, if you're asking what is a parameter, let me do some cool recall for you. So parameters are just basically these things within the parentheses, which is like a placeholder, all right? So you could put, whenever you call the method, you could put anything that's that's appropriate to its type. Okay, so the type for this is particle system, and we know that both right engine particle and left engine particle are instances of some sort of particle system that we dragged inside of the inspector panel using the serialize field, right? So in other words, whatever you put inside of these parentheses, it first has to be respectively put it like you have to put it respectively. So you cannot just put particle system and then float. You have to put it in order. Okay, so you need to first put the A rotation. So the A rotation for us was, I think, add rotation. And I think add rotation, if I'm not wrong, was the amount, like whether the value will be negative or positive, so we can see whether we're going to move left or right. So that was what we were trying to talk about, so that instead of this method, we could automatically say to move left or right. That was the thing about A rotation, add rotation. If you're still confused about that, you could check the previous videos to basically clarify on what I'm trying to say there. But then we also have the left engine particle and the right engine particle, which is, it works because this is trying to store the particle system. Now, the cool part about parameters is you can use this as a placeholder name rather than using left engine and right engine. And if you think of it, it's going to reference that thing automatically. Regardless of wherever you've used the method, it's going to reference that particular particle. So in other words, it just saves you time rather than making a set of if statements saying that if this is left engine particle, if this is right engine particle, and that's just going to pile up your code, and that's not what you want. No. So we would use the particle system as a parameter. Okay, so hopefully I helped you clear that out. I said a lot right there, but you could always ask me some questions on the Unity Discord to figure out whether you really understood or not. Okay. And what I've done is the two things that we already did was freeze rotation and transform.rotate. So we can just ignore that because that was completely for something else. But what we do now is we follow that same idea that if this particle is not already playing, then we just make it play. And we follow the same idea that we make the particle.loop true. So we're going to access that component loop, which is the looping feature that has the trigger on and off, right? The check mark. And we're just going to set that to true. And it's automatically going to set that check mark to true. We're just going to check mark that. And then we're going to play that particle as needed. And then if you're asking me how to do that false, now don't look at the else statement. I'm trying to explain. Patience, buddy. Now you might be asking, how do we stop playing that thing so it doesn't keep on looping even when we're not pressing the A and D keys? Then we just make the else statement. Finally, you had patience. Okay, good. So we have that else statement, and we make the freeze rotation false. And we actually already had this else statement because we had to set this to false. But we also set the loop for both of the particles, not just for one of them, both of them, and we set it to false. Okay, and when you play the game, I'll just show you what I did again. If I play the game now, you should see both of them playing while it's looping, only when I'm pressing the button. Okay, so give it some time to play, to run. All right, so let's actually turn around. And you can see that I was able to keep on making that thing loop while I was pressing the D key, right? And you should also keep in mind that the left engine particle, come on, man. Please come down. Okay, so if you turn right, the left engine particle should come up. Please come down. Please come down. Okay, and if I turn left, the right engine particle should come up. All right? So, voila, we fixed that. We fixed that as well. And hopefully maybe your code was similar to what I was trying to explain there as well. All right? So, finally, one thing that I wanted to talk about was also how did I change the color of that particle? So, if you see carefully, very meticulously, you can see that the side thruster particles, if I'm going to click on looping and play it, you can see that the color, it's different. So how did I do that? So a lot of people in this server right now wanted to know, I think I forgot to turn off the loop button. Wait, turn it off, yeah. Just turn it off. Make sure both the looping for all the particles are turned off. Problems can happen. So if you were wondering how do we change the color, and a lot of people, as I said, wanted to know how to customize your particle even more, well, you can click on this color over lifetime. Color over lifetime is just, in other words, changing the color. And you want to click on that gradient looking thing. Do not click on the arrow, click on the gradient looking thing. And you can see that initially the color should have been something like this, right? So you want to create your own color. So what you do is you press this new button, and you start making changes from there. So I could just, I'll just show you, for example, what I did. So, I don't know. And if you want to remove a color, just click on it and just drag it out. Boom. So if you know Photoshop, you might be aware of this, but Photoshop has a similar kind of layout whenever you're trying to make colors over here. And basically, if you want to add new colors, you just basically click, just do one click, and just and then a new palette should come up. And if you double click on this palette, you can see this color kind of options come up, and you could change the colors as to whatever you want it to be. All right, so I'm just probably gonna give you an example of how I could have done, maybe, you know. And this probably looks good. Let's play the thing to just see whether it it hopefully doesn't look garbage. It's fine. I'm just trying to show an example. But you can see that I've done something like this. Now, if you're asking me, how do I do the same thing for the left engine particle? I don't know how to exactly follow, you know, that consistency, or how where I put what, where I put the location, right? I don't know the exact percentage, and maybe you do just because I told you here, but it would take a lot of time, right? But lucky for you, you can actually just go to the second particle, go to color over lifetime, just press on that gradient thing again, and boom, you can just, Wait, I think I forgot to do one thing. Hold on. Basically, what you do is just press the new button. Okay. Whenever you're done creating your own gradient color, just press the new button, and you should be able to store your own type of gradient option. All right. So now let's just go back to color over lifetime. Let's click on that, and you should see that the changes should also be applied to that as well. So you can see that. Let me just put this on loop so I can prove that I'm right. You can see that the change is also applied over there as well. Now, the thing is, I don't like it. It looks poo-poo. So I need to change it to this thing because I like it, okay? You can change it to whatever you want, okay? It's up to you. It's just that I have my own aesthetics liking, and that is a really bad idea. Don't follow that principle. Because whatever I like, everyone else like. That's completely wrong. Or sometimes it's right, but mostly it's wrong. So I'm just trying to tell you that don't go by that kind of idea when you're making your own games. Anyways, let's turn off the looping and change the color to what I want it to be. But that's essentially how you can customize your particle even more. All right. And also one more thing before we, this is a really heavy topic today. Just 30 minutes of the meeting, we're just on updates. Don't worry. There's not a lot to talk about today in the new topics, but going back to the topic, let's do this quickly. If you play the game, right? If you start playing the game, you will realize that whenever you're hitting a particle, while you're holding the spacebar, you could see that the rocket engine, the thrust, it's still playing. Okay, and you don't want that. Like, if you're gonna play the game and the rocket particle still emits while you're still crashed, I don't know. You could still keep it as that if you would like, but usually I don't like that kind of aesthetic, and maybe for you, you might not like it as well. So a quick fix to that is just usually go to the collision handler script, and what I did was, well, one, you want to stop the engine particles. So what I did is for both of the cases, which is finish and default, not for the friendly, because you're not going to do any kind of sequence there or any methods or any kind of thing there. It's just we're ignoring it. That's the first thing. But I made a method for both the case finish and default. I made a method called stop engine particle. That the first thing I have to do is reference the particle system for all the three engines. So I have the main engine, which is the engine stop particle. Then I have the LE stop particle. So basically, in other words, left engine particle. And then RE is the right engine particle. And then I have to go back to Unity, click on the rocket. Now, make sure you do this inside of the prefab so it affects all the other prefabs. I'll just do that right now so I don't be a hypocrite. And just, respectively put all the particle systems, and carefully, as I said, please carefully put it, for the left engine, right engine, and the main engine. Okay, so just do that quickly. And then once you go back to the code, we'll make the method for the stop engine particle itself. So let's go down there. It's down here. And basically just stop all the particles. Let's just stop the engine, stop the main engine particle, the left engine particle, and the right engine particle. And that's really it. That's what I did to, fix that part. So to just give a demonstration that it actually works, let me just show you. So just hold the spacebar if you're trying to do this for yourself to check how to play test. So let's just play this. And I'll hold the spacebar while I'm going through. So I was voiceovering what I was trying to say. But I'll hold the spacebar while I'm touching an obstacle, and you'll see what happens. And you can see that there's no rockets emitting outside now because I fixed that mistake. So just keep in mind that sometimes when you add that looping feature, some other consequences can come by. So just make sure you're aware of that and see whether that's actually true or not. Okay, so that could be in your future updates or in your future patches for your game. So just keep in mind that usually whenever you add a new feature, it has a lot of upsides and downsides to it. To just keep that in mind while you're making your own decisions in your own game development journey. All right, that was a lot for just just talking about the updates that I made in my game. So let's go back to our main Google Slides. So this is refactoring. So the main idea that we'll talk about today is, usually when you make your own games, as I said in previous videos, like all the time, bro, like all the time, your code can get really, really complicated. Or in other words, it can get really, really long. Usually when a code is too long, that is usually the chances are very high, that's what I'm trying to say, that your code can be very complicated. And especially during the times when you really need to fix your code or add some updates or patches into your game, you might not know where is what, okay? Like let's say after 5 months you came back to your game and you wanted to make more changes to it, you decided to do that. Or maybe even like not 5 months, but like maybe longer than that, who knows? My point is like, you're probably going to get confused like what's going on in your code. So usually simplification is the key to success whenever you're making your own code. Now, obviously, do not simplify your code too much because then you can't do a lot with it. So already know that there's already a downside, a con with using simplification in your code. Okay. I did talk about what refactoring was back then, but I kind of want to just go over it again because I didn't really make a video on it. So that, whenever you're trying to access my GDC channel, you can just Control F, type refactoring, and come to this timestamp of the video, which will be attached in the description. All right. So really, I want to explain to you with an analogy of how you could understand the idea of refactoring. Say that you have like a type of a bottle, okay, and you have a set of statements over here. All right. You have like let's not say set of statements. You have like the ingredients for a salad, okay? So you have like tomatoes, you have cucumbers, you have carrots. I don't know what's in your salad, but the idea is picture the vegetables that you would put in your salad. Now, if you don't eat salad, just picture that you're eating a salad and just think of what, ingredients you would think of first, and just picture that in your head. Now, your manager or your mom is saying, hey, I want like 5 of those salads that you're making, right? So are you gonna, separately take these ingredients and make it all the time just by getting these ingredients separately and then making it again, then getting these ingredients separately and making it again? Or would you put these ingredients in a bottle or in that capsule that I was talking about, store it, and whenever I want to make a salad, I just take that bottle and boom, I got all the ingredients. So instead of going at different places to get the groceries, or if you're at Gourmet or at Villa Market or wherever you are and you have all the groceries, lucky. But just imagine that these different vegetables come from different places, right? You just hear me snore. I'm sorry. But my point is, you get different places. But instead of getting from different places, you could just have a bottle and have everything there for you. And whenever you want to make a salad, just get that bottle and boom, you got yourself a salad, and you can make like 5 times really quickly. And that analogy brings us to the idea of refactoring. Basically, whenever you're moving a set of statements, now let me just go back here. Whenever you're going back to our code, like an example, let's say over here, debug.log, congratulations, you got leveled up. Instead of having stop engine particles, if I took these 3 different things and just pasted it, like, for example, if I just pasted it, it's taking too much time. Oh my God, just like, So like if I instead of just having this one method, if I just really put all these 3 statements over here, yeah, you're gonna get the same outcome. Cool. But you can see that the amount of lines has changed. It has increased actually. So that's the same idea about refactoring. You could actually take these 3 different separate statements, put them in one method, and just call the method itself. So putting these statements in a method is called, you're encapsulating, that's the right word, you're encapsulating these methods, these set of statements into a method where you could call the method and really it will just run the code for you. Now, if you were going to follow that principle where we just don't give a crap about this method and just go along with our journey of just doing this thing, you could see that eventually when you follow the idea of just not making a method, or in other words, not refactoring your code, it's going to start increasing a lot, by a lot of times. And the thing is, you want to start simplifying your code so that you could start seeing things really very quickly at the instant time, more efficiently. In other words, more effectively. You're gonna get a less chance of making some errors in your code if you have simplified your code. But again, that also comes to the cost, right? The more simplification you make, you can't really make your game more complicated in a good sense, not in a bad sense. If it's complicated in a bad sense, and I'm sorry to say, but that's not a good game, right? So let's try to make a game a bit more complicated in a good sense. So you start to do more cool stuff in the game, make more cool integrated methods, more cool features in your game. That's what I'm saying about complicated. That you get a lot of cool features in your game, cool game mechanics basically, and the more simplified the code is, the less you will be able to do that. So just keep in mind where the balance is for you, and really practicing this idea more and more will just really give you a better idea of how to code in your future projects. Okay, so that's the idea of encapsulation. If I'm gonna play slideshow, it's gonna keep on loading for years, and hopefully I just wish they don't do that. It's just gonna do that. It is gonna do that. Why did I decide to play the slideshow? Okay, so basically that's the idea of encapsulating. So honestly, the right word of that is just refactoring, right? So don't try to say I'm encapsulating these set of statements in a method. Don't say that to a computer science dude. He's gonna be like, "Are you nuts? Like, what, cuckoo head? Like, what are you talking about?" Don't do that, okay? Just say that you're refactoring your code. A better word for this is like there's abstraction in your program. You're trying to simplify your code, and really like talk directly less to the computer. And more like just looking at the code itself rather than being able to directly tell the computer in binary code, right? Obviously, we're not talking in binary, but we're trying to simplify code more to make a higher level programming language. Not a language, but a programming language. You get the point. You're trying to simplify your code. But let's now talk about cheat/debug keys. This is the time, okay? You want to start cheating in your game? Boom, boom, boom. I don't condone cheating, especially when you're playing other people's games. But when you're making your own game, man, it's just a pain to just play these 20 levels you made and checking the last level whether you made that change or not, as I mentioned before. So, what's the right solution to this? What's the right way to really fix that problem? Like, dude, I don't want to play 20 levels. I just want to instantly go to the 20th level and check whether it's done or not. Okay? And so this is really essentially how you do it. So how to do it? Well, first, what we're going to try to do is we're going to try to make a way where we could press a button, which is the L key. So if you press the L key on your keyboard, you should be able to automatically load the next level, right? And it kind of makes sense if you think of it, kind of makes sense intuitively that we're using the word L because it really relates to the word level, right? And next, we're going to try to disable collision. So in your game, maybe, you want to disable people attacking you. So when people attack you, your health doesn't go away. That's a bit like a cheat code, right? But in our case, we don't have any enemies in our game, at least not yet. If you're making your own game and you have your own enemies, that's actually pretty dope. So just keep that in mind. If you're going to make your own game jam, maybe that's a cool idea. But what we're going to do right now is we're going to try to understand how to disable the collision, because collision is essentially like our enemy. If you're going to touch some obstacle, we're going to die and practically come back to that first level again. Not the first level, but the level where you are, and just play it again until you get to the next level. Right? So we want to find a way where we could do this. So we need to maybe create some sort of method where in that collision handler script, because essentially that's the place where we have the method load next level. We also have that's essentially the place where it's responsible for handling, managing collision. Duh, like the name of the file says so, the script. And yeah, we're just gonna make a method that will help control all the keys. So. And the good part about making your own method is that you could just add more keys into the future without, getting to some other method and then referencing that method in another method. You can just use this method itself, which is just essentially responsible for all the code. So you could just comment out that code in the update method and boom, that's it. Just build your game and the players won't have access to these cheat codes. Now, if you're smart, maybe you could, but hopefully you're not that kind of person. So what we need to, why did I just decide to, oh my God, I decided to get out of the presentation. Bad boy, Russell, bad boy. Let's go back to our Unity game and figure out how could we do that. So let's go to our code, essentially. So what we could do, we could go to the update method. Now, I removed the update method before, so I just added it recently. But in the update method, we could make some sort of, method that's essentially responsible for our cheat code. So let's do cheat codes. Do cheat. I guess maybe the right method could be do cheat. Now the reason why we don't have that purple looking thing or whatever color it is, or in other words why it's unhighlighted, is essentially because we didn't make the method. So let's actually do that. So void is always that trigger phrase for making a method. So do cheat. Now I don't know why my code set to the capital letters, which has to be lowercase. And from here we want to do these kind of practically like say that, hey, if you're going to press the L key, then do something. If you're going to press the C key, then essentially do something there as well. All right, so let me just open my phone to just make sure that I don't do anything poo-poo head or cuckoo head kind of thing. All right. Okay, so actually one thing that we could definitely do right now is we're essentially getting the idea of like this thing, right? We're trying to do something with keyboards, like what is it called? Basically, whatever you're doing is key inputs, right? So what we do is we could just follow the idea. It's basically just copy pasting, practically, all right? So we could just do get key, and this time we could just do get key down. So like whenever you pressed it down, the moment you pressed it, then it's gonna run it. If you're still confused about get key down, get key up, and get key, I've mentioned that in my previous video, so you could still clarify that as well. Dang, we have a lot of videos for everything. It's pretty impressive, but. Actually, not key code A. So now this is where you need to keep in mind. We're not going to press the A button and move to the left level, right? Because if you're going to keep on pressing the A button, that's also responsible for turning. And that's going to essentially make us go to the next level. And everyone's going to be like so confused. What just happened? Did I just time travel? No, daddy, you didn't. So now what we want to do is when we press the L button, so keycode.L, we want to do something. So we want to do something. Okay. So we want to know what can we do that when we press the L button, how do we go to the next level? Load next level. We already have a method, bro. Got a new method. Load next level, which is basically the method that's responsible for going to the next level. Right? So we can basically, bro, it's so easy, bro. We can just call the method, bro. Oh. Okay. Load. So we can just call the load next level. Parentheses. Boom, boom, boom. Let's actually try. Let's not excite ourselves too much, you know. You wanna try running the game and check whether it worked or not. Because if it doesn't work, that's sad, bro. We gotta check it because you shouldn't excite ourselves so much. Game developers are not exciting all the time until we get a good game. Okay. Anyway, so let's press the L button. So let's play. And if I press the L button, boom, we got to the next level. Let's press the L button again. Oh, we got the next level. You get the point, bro. So it works. That cheat debug key works. Now you might be asking, hey, bro, gotta listen, bro. What if the players who are playing the game and you build the game, if they play it, they're gonna do the same thing, right, bro? Well, bro, you could actually just comment this code out, bro. Or in other words, you could just remove the update method and be like, bro, that ain't gonna work, bro. You ain't gonna get that cheat debug keys, bro. All right? I said bro so many times. I'm apologizing for that. Now we want to try for when we press let's go back to our presentation. When we press the C key, we should be able to disable the collision. So let's try to find a way to do that. Okay, bro? All right, step, bro. All right, get key down, key code dot, and we went. Sorry. Key code dot C, and C is responsible for it's responsible for handling that thing. Where if I toggle the C button, it's not gonna allow us to get hurt by the obstacles. You know, you got that cheat code. The first thing is. We already have, on collision enter, which is responsible for a switch statement. And if you still don't know what switch statements are, we got a video for that. Boom! Look at how many videos we got. Oh man, we got so many videos to talk about. And if you still don't get it, it's all right. You could search it up on the internet. But GDC videos are amazing. Trust me, bro, is my source. So we need to figure out how do we find a way to disable collisions, like we have some sort of on collision enter, And then we have like start destruction sequence, start success sequence kind of things. And all of them are part of this thing. So we should get an idea that we need to do something within this as well, right? Because this is where we're going to put the statement. And this is the entire area, void on collision enter, is responsible for the collision part in our game. Right? So what we can do first is we could make some sort of Boolean. Remember like in the last class or 2 classes ago, we talked about Boolean conditions. You can make your own condition in the game. We made a condition already, which is transitioning, which basically, I think in other words, if I'm going to, I'm going to use Control F because I don't know what I did for that. Transitioning. All right. So we can see that I think if it was is transitioning, I think it's because like if I'm not wrong, I'm not really sure what I did that there for, but there was a reason, okay? There was a reason. And that was essentially responsible for some sort of condition in our game. We made some sort of status that if that player was perhaps transitioning in this scenario, so that's kind of a alert sign for me that this is not a good name because I don't know what it's doing, right? So that's the idea. So we can make another Boolean condition, and this could maybe be like, hey, is collision, right? Or maybe a better word. Let me find a better word. Is collided? Maybe is collided might be a better word. And we could set this initially to false because, or maybe we could say stop maybe we could make collider cheat. So this is basically responsible for like, hey, if I'm gonna, if I am like, this is gonna be responsible. Hey, whether I'm able to cheat in the game or not. So especially like I can avoid the obstacle collisions and stuff. I mean, obviously you will be a collider with these obstacles, but you won't die really, right? So we're gonna initially set this to false because in the beginning of the game, we're not really essentially like using that cheat code. It's just like whenever you want to press the C button, it's gonna toggle that cheat kind of thing. So what we do here is we go to the if is transitioning. So because this is where the Boolean conditions are really being controlled, right? So we could, I think, if I'm not wrong, we could just say is transitioning or a collider cheat, right? And basically, in other words, when I say or collider cheat, it's just saying that if collider cheat is equal to false, which is initially set to that, then we would just, return it, right? So that's what I'm trying to say there, if I'm not wrong. All right, so then what we would do here is we would set the collider cheat to true. Or no, wait, no. We would say not collider cheat. So this is actually something I wanted to talk about, not collider cheat. So what does not exclamation mark? I already talked about previously what exclamation mark was, which was just another word of saying not something in the game. So if it's not collider cheat, so in other words, not false, you make it true. So if we will just make collider cheat to true, and then we could just basically run the game as needed. All right, so I'm still feeling that I'm missing something in my code. Let's see. And maybe we could maybe do debug.log. Debug.log is like saying collider cheat enabled. So it's just like saying in the console, it's like a good way to communicate with the developer that you've done something inside of the code. Because usually you can't physically see whether you have made whether something has been changed in your game, right? Because of some program that you did in your code. So we could say collider cheat enabled, right? And we're just gonna see that if that's the case or not. Or maybe I would not want to do that, I don't know. Or maybe I could say if collider cheat is true, collider cheat is equal to true. Sorry. Is equal to true. I'm doing these things I don't know, out of my head, so it might not work, so just bear with me. So I could just make debug.log, that, and I would just say else if collider cheat equals to false, then I would just copy this entire thing and just say it's disabled, if I'm not wrong. Right. Maybe I think that's how you do it, if I'm not wrong. Or I forgot to say disabled. Okay, let's try running it. I'm doubting myself already. Let's just see if it's gonna work or not. Okay. So if you press the C button, we can see that collider cheat is enabled. So you can see that if I'm touching the obstacle, it's not working. Now if I press C button again, it's gonna say collider cheat is disabled, which basically indicates that I've disabled the collider cheat thanks to our console panel. And what we can do is, what's gonna do is whenever you collide with an obstacle, it's gonna do what it's supposed to do, get that death sequence, or just basically make the rocket explode and die. So basically, when I press the C button again, the collider cheat is enabled, so I could, do whatever I want, and just easily. And you can see that this is one bummer. When I press the C button, I can't, go to the next level. So to press the C button again, and I die. Okay, let's try this again. So collider cheat is enabled, and let's just press the thing again. Oh, sorry. But we've seen that it works. Oh my God, I'm a cheater. I'm a hack. Don't say that, Russell. That's a bad idea. Someone's gonna record me saying that I'm a cheater. No, I'm not. I'm a good man. I'm a good man soul. I'm a really nice guy. But we've seen that we could, add some cheat codes in our game, and we did some hacking, okay? Thanks to Unity. But you're not going to be a real hacker because there's more to hacking than you ever thought of, okay? So that's the main thing about, cheat/debug key. So let's go back to our code and see whether we could maybe do another debug.log for the next level. So I always recommend having practicing to add these logs inside of your game, these debug logs, because it's really going to help you whether some things in your program has happened or not, whether up to some point in the program that's happening. So we can see that the program's running correctly to see whether there are any runtime exceptions, right? So basically what I'm trying to say is the program runs, but you probably see some minor error in the game, which you can't really see until you really dig deeper into the game. So, and debug.logs can help you find these minor errors. All right, so we can just say load in next level. We could just do that, and we can go back to our game. It's gonna load. All right, so so let's actually press the L button, and you can see that. Oops, let me just do that again. You can see that the thing came up again today. Not today, but it came up, right? Load in next level. So it's a really great way of seeing whether something's working or not in your code, and it's a great practice to do as well. So that's that on cheat and debug keys. And finally, we're going to go on our final thing before I let you guys go and talk about the assignments, which I don't think I'll tell you in this meeting. You'll see that automatically in the assignments channel once I post it. And this is going to take a few seconds to load. I'm sorry for doing that. All right. Yeah, so we have designing the environment. So finally, we're going to start designing the environment. Because if you look at our game, look at the surroundings, man. It looks so bad. What are you doing? We have to do really good, okay? If you're trying to make a good game, try to make your game look at least aesthetic to some sense, okay? You guys could go to the Asda store or someplace to at least get these things. All right, so let's go back and talk about maybe some cool ways to make your environment look unique to yourself, right? To make your environment look special and good. So first thing you could do, you should do, but what I recommend is use the obstacle prefab. So if you go to your prefabs, thanks to our really, really organized folder, you can see that the ground is located here, all right? And I don't recommend renaming. I don't recommend renaming the thing, but you could just do this. I'll just change it to obstacles. All right, I think it works. But what you should do is you should just add obstacles accordingly like that. Now you might be asking me, well, I don't like this color. Ooh, it's so gross, bro. Well, you could just go to your materials, right? And essentially, this is where your materials are. Now, I think a better word for ground for this type of material is the obstacle. Just type obstacle and you should already know that it's a material for the obstacle. And you can just basically practically change the colors as needed from here. Right? I'm not going to do that, but I'm just saying that it's really easy to just change your colors accordingly. Now you could just add more materials and change colors for each type of obstacles, that can work as well. But it's completely up to you. Make your environment look unique, all right? And use that Q prefab, which is more recommended because all of that prefab has the code, or in other words, has that tag obstacle, right? So that's a benefit. Now, if you don't want to use the thing like the prefab, you could just change that new object you add into the environment, and just change the tag for that to its appropriate tag. So if it's an obstacle, change it to the obstacle tag or whatever tag you used to reference that type of thing inside of the collision handler code. All right. And add some depth. So depth meaning like add some 3D kind of feeling in the game. Make it look realistic. Don't make it look like a platform or a game. This game is essentially like, if you think of it, like a 2D platformer. It's just that we ported it into a 3D kind of game. Okay, into a 3D kind of level kind of thing. So try to add some depth. Depth is essentially one of the factors that makes a 3D, 3-dimensional. Right? So try to add that. And again, use that intention to execution principle. So for me, I want to make a Mars type of game. And that's my intention. So my execution should follow the idea of a Mars game. So that's what I'm trying to do. That's essentially the reason why I made everything orange inside of my game. Now, before I do anything, you can see that the asterisk is right there, which just indicates I've been saving my game. So just Control S, save that quickly so you don't cry if your things have not been saved. All right, and another thing you should also keep in mind is attempt to make your world, or in other words, frame your world, so that, or in other words, you want to adjust your world in a way that the player can't get out of it. Okay, so if you see this, what I'm trying to say here is, don't make your game as if the player can get out of it. Okay, so you can see that the game has a boundary over here. It's like you can see a boundary at the left, boundary at the right. You could do that via code by saying that within these axes, if you go, below that, then just make the player not move towards that area. Right? Same thing for here, same thing for top. But try to integrate your environment accordingly. Try to make the player not touch the top and left part. Okay, so you can see that, for example, if I'm just gonna move left, there's nothing making me stop from moving left. And I can just move continuously and not know where I'm going, right? And that's what I'm trying to talk about. Same thing for the top, same thing for the right. So try to create some sort of domain, or in other words, some boundary in your game, like naturally, just from the environment itself, that tells the user to be constrained within these areas and not move it beyond that. Because I know that there are a lot of gamers out there trying to find mistakes in your game. And bro, I don't want to see that happening, all right? I just bro to bro kind of advice. Let's not do that, all right? You should make your game amazing, and let's not make these people make your game, all right? And obviously, not doing this, as said, could ruin the player experience. Like, you don't want the player to just get out of the boundary and make that guy just keep on pressing the space bar continuously, not knowing where it is. So then they will not know how to come back up there. Like, you could have just seen me. Like, I was getting confused. How do I get it back up to my environment? Because I don't want to just stop playing the game and then play the game again, right? I don't want to do that. So that's the thing. Just keep that in mind. All right. So another thing. So now let's actually try, making our game. Like, try using the idea that I was trying to talk about. Now, before you start, if you have already started like watching this video and you already added the obstacles, it's fine. But what you want to always start first is by creating an empty object and naming it obstacles. All right. And within that, put the stuff as needed. All right. Now, I think for me, I was a Dumbo, not realizing that I renamed something wrong. I shouldn't have done that. So this was supposed to be the ground, which was essentially also like a obstacle prefab, if you think of it. But I'll just put that below the obstacle as well. So just think of it as these two are separate obstacles. All right. And I'm just going to go to the materials and change this to the ground. Or I'm just going to make it called obstacle. Or maybe not. Maybe I could make the ground some other color and, stuff like that. All right. But what I'm going to do first is I'm going to go rename this. And I'm going to call it an OBS. I know it's an app. Please bear with me. But you could just drag that and make it a prefab. So what you can do is you could just make instances of that prefab in the environment. Make as many as you want. And I'm just going to create a material. And I'm maybe going to create another type of material for these specific type of obstacles. And I'm going to call it OBS. Yeah, OBS mat, all right? And I'm just gonna drag it to one of these things. So I don't know which one is what. um, yeah, so I guess this is the main one, OBS. So I'm just gonna drag that to that thing, and I'm gonna change the color to, I don't know, something like this. And you might be wondering why it has not applied the changes to the other two. Well, it's because I just applied to one instance. So what I have to do is click on overrides, click on apply all. Did I apply all? I didn't. So just press apply all, and now you can see the changes have been applied as needed. Now I don't like this color. It's kind of garbage, so I want to try to change the color to something else perhaps. For now, I'll just keep it as a placeholder color. Obviously, I could come back in the meantime and change it. But you kind of get the idea that that's what I'm trying to do. And what you need to do, basically, is just play around with these objects, all right? You could play around, move the thing. So, as I said, try to move the object, like, try to make some boundary. And you should always keep in track what your environment is doing, so where the objects are relative to the environment. So what I recommend while you're making your own game is just put this on split screen or something where you could, see the game, all right? Maybe this is better, so you could see like where things are what. Now, this is kind of a bad idea of doing so because your FOV has changed. So honestly, you could just keep it here as well and just switch the tabs to see what's going on. Now, this also comes to another tip about local versus global, all right? So you can see this on the top left, as I mentioned. There are two buttons, local and global. You have not seen any changes, but let me try rotating the object. Okay, let's rotate it to the x-axis. Something like this. All right, and let's come back. Let's press the W button. And now if I press global, the coordinate system has changed. You can see that it went from here to here. It has straightened it. And if I press local again, it has changed like this. Now, why is that? Now, let's talk about local versus global. This is actually a very, very good topic to discuss about, especially when you're coding. Not right now, but in the future, you're totally going to want to learn this. Thanks to some guy on Unity Hub, Lord of Duct. It's a kind of weird name, but that's the point of usernames on the internet. They're all weird. But thanks, this guy, he explained it really well. So we want to first understand the idea of what local space is. It's just basically transforming, like when I say transform, like rotating, scaling, moving relative to its parent. Now, it doesn't always have to be the parent, right? Like this thing doesn't have any parent object. It's not a child of any big parent object. It's just an object itself. So it doesn't really necessarily have to be the parent, but if it's not a parent, you could just say relative to itself, right? So you're basically moving relative to where it is, like relative to the object itself. If it's not a child object. If it is a child object, it's gonna move relative to the parent object. So in other words, for this one, this is gonna move relative to the obstacle, right? But actually, if you think of it, if I rotate this, I don't think that should be the case as well. I could just press this, and you should see that it's moving relative to the object. So forget what I said about the parent object and stuff. What local really is, and let me just undo everything I did there. Local is just basically you're moving, rotating, scaling relative to where that specific object is, relative just to the object itself. Don't care about the surroundings, don't care about the environment. You're just doing things based on how the object itself is oriented. So since we have turned this by x degrees forward, or I think z degrees, it was x degrees, you can see that now the changes will be applied relative to that direction, relative to where its coordinate is, relative to the object itself. Whereas if we were going to use the global, it's going to be relative to the entire environment itself, relative to the other obstacles and the scene itself. And I can see the scene is straightened. So that's the idea. So even if you're going to like rotate this, it's still going to be straight. Regardless of you even rotating to how you're going to do, it's still going to look like this because it's relative to the environment, all right? Not relative to the object itself. So let's actually confirm about what global space is. It's just essentially, it's just combining the transformation of that object and just, moving that in relation to the root of the scene, to just the scene itself. So let's again confirm what I was trying to talk about. If I was going to just rotate to, like some really weird style, right? And I still go back to the W, it's still gonna look like that. But if I'm gonna press the local, it's gonna move relative to just the object itself. It's gonna ignore the surroundings and just move relative to where that object is in the environment. And local and global is just gonna move relative to where the scene is. Scene is straight. It's always straight and fixed. So this is why when I was rotating, this hasn't changed at all because it's moving relative to where the scene is, not where the object is. So hopefully that clears out about what that thing is, what that thing is just in general. And that's really that on local and stuff. But what I want you to do today is basically add these different things, right? So what I'm going to do is I'm going to add these two things inside of the obstacle parent object and just basically play around. So one way I would definitely do is just play around with the surroundings, whatever you want. Usually play with the rotation, play with their length. So use the R buttons and just do whatever you want. Go crazy with it. And one of your assignments eventually today, like for next week, submit it anytime next week, is to basically submit one of your type of environments. So I wanted to show you, before I end this meeting, the game that I made, the type of environment I integrated there. And I think I should crash the thing first because I didn't straighten it. But you could see that I have integrated the environment like this. Now, one other thing that I have not talked about, which I should have, was to create your own Skybox. All right. So it's easy as it is. So you could just make a new material, call it Skybox, and basically change from standard to Skybox and to procedural. So this will just allow you to edit your Skybox as needed. Now what you need to do is go to layout, and I think rendering and lighting settings. And you can see that there is a default There's a default Skybox over here. What you just do is just drag that. All right. And someone's calling me. It's fine. So take the Skybox, and what you can do is you could go crazy with it, really. You can just edit these things. You could change the sky tint. You could change it to different colors as you'd like. You could change the exposure of the place. So you can see that in the game, not like right now in the scene, but in the game. And you can see what's happening in real time. You could change the atmosphere thickness and all that kind of stuff. I think Mars have like, an orange kind of, it's too orange. Maybe something like that. And maybe, something like this, and change the thickness as needed. And honestly, just go crazy with it. Like some people just keep it in the darkness, or some people just keep it like this. So this really looks good for me. It looks dark. It's getting dark over there and stuff. You could change the sun size. So when I'm talking about the sun, it's just the size of the sun itself. And really just go crazy with it. This is how you make your own Skybox, all right? And that's really it on how you make your own Skybox really in your own game. All right, so that hopefully that kind of helps. So let's debug, let's just do some type of, what am I going to say? Before I end this meeting, let's talk about some debriefing. One, I have added some cheats/debug keys. I have added some, environment design. I taught you how to make your own Skybox. I taught you also how to make your own environment using your own prefabs that you already made. So congratulations to that. You could also use the things that you made already and make use of that in the future. And that's one of the ways to do it. And I also explained a bit about local and global, how we can use both of them. Local is relative to the object. Global is relative to the scene itself. And then I talked about refactoring. Refactoring is like simplifying your code. And then I also talked about some updates, like how I loot my thrust, so it kind of feels a bit more realistic to avoid that, problem in player testing, player experience. And then I also talked about how I added the jet particles for the left and right side, respectively. And then I also talked about how particles crashed, how do I stop all these particles whenever I crashed while I was holding it, right? That's one of the conditions. So that's really that on today's meeting. The next meeting, we'll be talking a bit more about how we can make some oscillations, some movements with our obstacles, make it a bit more lively, and really that's it. So and maybe there's some things about how to make some spinners, which I've already talked about in the previous project, but we'll still go on that today and next week. And then a bit about how to publish your own game, some tips on marketing your game, especially if you're trying to make money out of it. So that's that. So yeah, that's really it for today. Thank you for joining you all, and I'll see you in the next meeting. Peace.